Hello Physics Nation, my name is Nate Larmond. I'd like to talk about our first AP Physics quiz for fall 2017, and it's about vertically launched projectiles. We have one question in full generality and then one practical question. So here we go. We're going to launch a projectile vertically up, away from the surface of the Earth. You measure the hang time, the total time of flight up and down, to be capital T. We assume the acceleration due to gravity to be g. Ignore the effects of air resistance. For part A, we find the launch velocity in terms of t and g. And for part B, we find the maximum altitude, the change in vertical position above the point of launch in terms of t and g. So, how do we do this? Well, for the first part, the launch velocity, all we need is the definition of acceleration. Acceleration is the change in velocity divided by the elapsed time it takes to make that change in velocity. And we're going to do a common trick for vertically launched projectiles. We're actually only going to look at the up half. Why? Well, because it stops moving vertically at the top of its flight. And this turns out to be convenient because when you substitute in the final velocity to be 0, this term drops out. All right? So this delta t, if we're only talking about the up half, is called the apex time, the time it takes to get to the top, and that's half of the total time. So that's the other substitution. We're going to take this term and put it in for the elapsed time. So no final velocity minus the initial velocity divided by the total time divided by 2 equals the acceleration due to gravity. We multiply both sides by this term, t divided by 2, and we end up with gt divided by 2 equals negative vi. That just means vi equals negative gt divided by 2. Not that bad. Why full generality? Well, the functional relationship becomes obvious. So if you double the total time you're in the air, or the projectile is in the air, you will have to move twice as fast. If you triple the total time, you will have to triple the launch velocity. The hang time and the launch velocity are directly proportional. And this is the coefficient of proportionality, negative g divided by 2. Anyway, this is more interesting in the next question. Find the maximum altitude, that is the biggest change in vertical position in terms of t and g. Well, change in distance equals 1/2 at squared plus vit. This is one of the big 5 they say you should memorize. And we're going to do the same trick. So we're going to focus on the up half of the projectile, that is the final velocity is 0. And we simply substitute in our answer that we calculated for the initial velocity where vi shows up. So 1/2 t squared becomes 1/2 g t divided by 2 all squared plus vi t divided by 2. But what I'm saying is vi becomes negative g capital T divided by 2. All right, the physics is done after this step. It's just all algebra. So the math teachers say we distribute the exponent. T divided by 2 all squared becomes t squared divided by 4. Negative gt divided by 2 multiplied by t divided by 2 becomes negative gt squared divided by 4. And look at this. 2 times 4 is 8. So we have gt squared divided by 8. And we have a gt squared in each one of these terms. So we can pull gt squared out and do 1/8 minus 1/4. That's negative 1/8. And so finally we're left with negative gt squared divided by 1/8. So check it out. Double the hang time now means 4 times the maximum altitude because of this exponential relationship. 3 times the original hang time, 9 times the original altitude. So the functional relationship between hang time and maximum altitude is now a parabolic function, not a direct function like it was between initial velocity and hang time. And so there you go. Isn't full generality fun? See you in the next video.